Hello, this is Mrs. McBride, and earlier today I talked to you about the different classifications of matter. Matter can be identified as an element, compound, or mixture. Today I want to talk to you about the different traits of matter. Matter is made up of atoms. Keep in mind that matter is anything that has mass and takes up space or is a volume. So if we're looking at matter, there are two main traits that we should be looking at. We should be looking at the properties of matter and the changes that matter goes through. When we talk about properties, we're looking at something that is observable or something that can be measured. When we talk about properties, properties can be divided up of matter into physical properties or chemical properties. When we say physical properties, we are saying that the substance does not change. But when we talk about chemical properties, now the substance can change. So physical properties can be broken down into two distinct categories. It can be either identified as intensive or extensive property. So when we're talking about intensive physical property, keep in mind that intensive starts with an IN. So we are talking about the internal or inside of matter, what is actually happening. So intensive property does not depend on the amount of the substance that is being studied. So the amount of the substance, whether you have a drop of a substance or whether you happen to have a whole ocean full of water, the amount of that water does not make a difference as far as the intensive goes. So if we're looking at melting point, boiling point, freezing point, any one of those temperatures, that would be considered to be an intensive property. It does not matter whether I have a drop of water and that drop of water will freeze at 0 degrees Celsius, or if I happen to have a whole a swimming pool of water. The swimming pool will also start freezing at 0 degrees Celsius. Another intensive physical property to look at is something called malleable. Malleable means when you take a substance and you flatten it out completely. An example of something that is malleable is aluminum foil. You can take aluminum foil and you can completely flatten it out. Ductile is another intensive property. It does not make a difference whether I have a small piece of copper or I have a whole spool of copper. Copper can be made into wire. The word ductile means to make something into a wire. So I can take a small piece of copper and make that into a wire, or I can take a whole spool of copper and I can spin that into a wire. Conductivity is another example of intensive, where electricity does conduct through it. Electricity will conduct very easily through that small piece of copper wire as well as a whole spool of copper wire. Metal is another intensive property, and metal just means that it is shiny. Aluminum foil, whether you have a small piece of aluminum foil or you have a very long piece of aluminum foil, it is still shiny in the same amount. Molecular shape is another characteristic of intensive property, where when we talk about molecular shape, we're saying that the molecules have a particular shape. It does not make a difference whether I have a small amount of a substance or a large amount. The shape of each molecule that is present will also be the exact same. Molecular shape also tends to give texture to a substance. Color is another intensive property where regardless of the amount of a substance, the color is going to remain the same. Think of aluminum foil again. The color of aluminum foil is that silver color, whether I have a small piece of aluminum foil or a large piece of aluminum foil. The color just does not change. That is because it is intensive. It does not depend on the amount of substance that is present. Compressibility, another way to identify compressibility is to discuss pressure. So you can look at pressure or compressibility, and I can still press. I can take 5 milliliters. I can take aluminum foil, and I can put pressure on it, and I can press it into a small ball, or I can take a large piece of aluminum foil, a whole roll, and I can press that into a round ball. Density is another example of intensive property. Density, as you know, is mass over volume, and the unit is grams over milliliters. The density of water, whether you have a small puddle of water or an ocean full of water, the density of water will still remain the same. Extensive, on the other hand, you guys, starts with an EX, and it means external or outside. So this depends on the amount of the substance that is present. So if I have shape, mass, volume, and size all depend on the amount of the substance that is present. If I have a small amount of aluminum foil and I want to make a reindeer, I don't know, make a horse out of that or something, then it is very difficult to make a sculpture of a horse from a small piece of aluminum foil. But if I have if I have a large roll of aluminum foil, then I can easily take that roll and make a sculpture of a horse. Mass also makes a difference. It depends on the amount of substance that is present. Volume also depends on the amount of substance that is present. I can either have 5 milliliters of water, or I can have 13 liters of water. They're both different volumes. Size also makes a difference. There is a difference between the size of the small copper wire and the size of the spool of copper wire. So that these 4 characteristics, mass, shape, volume, and size, are all extensive properties. Now, if we look at chemical properties, this is where the substance changes. And the substance changes into a different substance. You can still observe it, you can still measure it, but when a substance changes through chemical properties, it's either going to react with water, it's going to be flammable, meaning it catches on fire quickly, or it's an oxidizer, meaning it reacts with oxygen. Usually when something reacts with oxygen, we know it as rust. And then, of course, we are also looking at pH, the pH of the substance. So these are all forms of properties of matter. Now, if we look at changes that matter can go through, the word changes actually means that now matter is changing into something else. It's changing into maybe a new substance, or something is happening to that substance. So if we're looking at changes, we can identify it as physical change or chemical change. Unlike a chemical change, a physical change does not change the substance, but something still happens to that substance. So we're looking at the properties. It still stays the same before as was after. So if we're talking about a physical change, We can look at water, and water tends to go through a phase change. So water can, you have ice, which is a solid. Now keep in mind that solids are a definite shape and volume, and the molecules of a solid are more compactly put together. That same ice cube can now start melting into a liquid, which is a different phase of water. Now keep in mind that liquids do not have a definite shape, but they definitely have a definite volume. There is a definite volume, and that liquid eventually, if heat is added on or increases, that liquid will eventually become steam and it becomes gas. Keep in mind that gases do not have a definite shape nor a definite volume. So phase change is an example of a physical change. The substance may not change into a new substance, but it does go through some kind of a change. Another type of a physical change could be when you're tearing something, pulling on something, pushing it, pounding on it, or even squeezing it. That is an example of a physical change. You can also take a balloon, inflate it, or deflate it. The balloon does not change into a new substance. It just, something is happening to it. It goes through a physical change where the balloon was once deflated and now it is inflated. Other examples of physical change would be dissolving something, mixing something, or even painting something. So with all of these different characteristics right here, phase change, or tearing, pulling, deflating, dissolving, you are never changing the substance into a new substance. Something just happens to that substance, and you are physically at that time just changing the substance. If you look at chemical change, on the other hand, when you have a chemical change, now that substance does go through an actual change where it becomes an entirely new substance, or where it has completely new properties now. And you can always tell that a chemical change is taking place because there is some evidence that is present when a chemical change occurs. You will see, when a chemical change occurs, you will see bubbles being produced. You will see a change in temperature. And when I say change in temperature, I'm not saying that the temperature will increase. Sometimes when you have a chemical change, the temperature will actually decrease. You have an unexpected change of color. The color that you started off with in a chemical change is not necessarily the color that you will end up with. For example, if you mix red and blue, well, you're going to end up with purple. It's an unexpected color change. Sometimes when there is a chemical change, there's also odor that is produced, some kind of a smell. There's also light that is produced, where you will see whether it be sparks or whether it be an explosion, but some kind of light is produced, and you will see the solid is formed from combining two liquids together. So you can have two liquids that come together, and all of a sudden now a solid is formed. When that solid forms, we call that solid a precipitate, and usually we give it the initial PPT. So usually when a precipitate happens, we can, and you are able to taste the substance. Not usually, but that usually happens when you are cooking. When you take two different liquids and put them together, there is a chemical change that happens. There is, of course, as you know, a change in taste also. So earlier, before you started listening to this lecture on matter, you actually observed an experiment happening. And it was basically a white powder that was in a test tube where a gummy bear was placed inside the white powder. And at first nothing really happened, but once fire was added to it or heat was added to it, eventually you, after some time, you saw a large spark, and you saw light changing, white light coming out of it. And then at the end, you saw the test tube had a black residue on it. That is an example of a chemical change. So going through this chemical change, understanding how matter is identified. Matter can be identified either as properties, or it could be identified as changes. Keep in mind that when we are talking about properties, matter does not really go through change. When we talk about properties, we are simply saying that you can observe that change, or you can measure that change. So last but not least, I wanted to talk to you about the different types of separation techniques. So the different types of techniques really goes along with classification of matter. When I talked about whether you can sort through something or whether you can filter it. So separation technique is really a physical change, meaning it is a physical change that is taking place where the substance really does not change at all. It's just that something is happening to that substance at that time. So separation is a physical change in where you separate maybe a mixture into its components. Keep in mind that a mixture can be made up of compounds or elements. And the separation does not change the components chemically because they don't really turn into a different substance. They're just they're the same substance, and so it's based on the physical properties of the substance that happens to where the separation technique works. So separation techniques are actually based on physical properties of the substance. So you have here examples of separation techniques would be distillation, recrystallization, evaporation, filtration, and chromatography. So let's start with distillation. Distillation is actually the separation of two liquids based on their different boiling points. And paper chromatography, on the other hand, is a separation of colored components based on their affinity for the stationary stage of the paper or the mobile phase, which is the solvent. So when I say affinity, I'm basically saying is that you have two phases in a paper chromatography experiment. You have the stationary phase, which is where the paper is, and then you have the mobile phase where the solvent is. And based on whether it's based on the attraction or the repulsion of these two phases on a paper chromatography experiment. Filtration, on the other hand, separates solids from a solid-liquid mixture. And a residue is left on the filter paper, and the filtrate is actually the liquid that filters through. Another type of separation that we have is called dissociation of ions in water. And what really happens is that if you have salt in water, let's say, eventually the salt will evaporate from the water will evaporate from the salt, leaving the salt behind in the container. So these are the different types of separation techniques that are present. The first technique that you see right here in the picture, this would be distillation. This would be your paper chromatography. And last but not least, this would be your filtration experiment that you have. Okay, so these are the three main types of separation techniques that we have: distillation, paper chromatography, and filtration. And this concludes our lecture on on properties of matter and changes of matter and separation techniques.